We are the GeminiPYTW team. In this video we will tell you a little bit about who we are and what we do. GeminiPYTW is a team that is participating in KIBO robotic program competition, KIBO-RPC, and it was born just a few months ago from the international collaboration between the National Space Organization of Taiwan, NSPO, and the Paraguayan Space Agency, AEP, delegating the management and leadership of the team to Jose Genes, who is pursuing a master's degree in space science and engineering at the National Central University in Taiwan. It started when the AEP extended an invitation from NSPO to the UPTP, Taiwan Paraguay Polytechnic University. Then the university decided to select 5 volunteers, 2 of them being electromechanical engineering undergraduate students, while another 2 from the computer science engineering department and 1 from the industrial engineering department. All of us are also currently studying in Taiwan, specifically at the National Taiwan University of Science and Technology. This is how the project begins, with the support of professionals from both nations, Paraguay and Taiwan. Some of these Paraguayan professionals that support the team are scholarship students that are studying in Taiwan, and others directly from the AEP. The name was decided between the members of the team, the coaches, the supporters, and the leader as a reference to the second manned spaceflight program operated by NASA, because it resembles what this opportunity means for Paraguay. KIBO-RPC is an educational program in which students solve several problems by programming free-flying robots Astro B and Interpol in the International Space Station, ISS. KIBO-RPC will inspire students to develop their educational and professional goals to a higher level. Participants will have the opportunity to learn cutting-edge methodologies and hone their skills in science, technology, engineering, and mathematics. Through this program, KIBO-RPC will also expand international exchange by encouraging students to interact with other participants from around the world. This program is hosted by Japan Aerospace Exploration Agency, JAXA, in cooperation with National Aeronautics and Space Administration, NASA. The mission of this competition is to repair an air leak caused by a meteor hitting the ISS by programming in Java the Astro B robot inside the station. Finally, we need to report completion of the mission to a crew member, and our score is calculated from the accuracy of laser pointing and the elapsed time. Astro B is NASA's new free-flying robotic system that helps astronauts reduce the time they spend on routine duties, leaving them to focus more on the things that only humans can do. Working autonomously or via remote control by astronauts, flight controllers, or researchers on the ground, the robots can perform tasks such as taking inventory, documenting experiments, or moving small items or cargo throughout the station. The Astro B system consists of 3 cube-shaped robots, software, and a docking station used for recharging. The robots use electric fans as a propulsion system that allows them to fly freely through the microgravity environment of the station. Cameras and sensors help them to see and navigate their surroundings. The robots also carry a perching arm that allows them to grasp station handrails in order to conserve energy or to grab and hold items. These robots will play a significant part in the agency's mission to return to the moon, as well as other deep space missions. Robots such as Astro B have the capacity to become caretakers for future spacecraft, working to monitor and keep systems operating smoothly while crew are away. As the Astro B challenge was a completely new and different kind of project, we sort of know about coding robots, but here on Earth, Astro B was a completely different type of robot to us. Despite still being a robot, it shall work in a zero gravity or microgravity environment that was new for us, but it is still coded in Java language, and the IDE and the SDK were also known in this case, the Android Studio IDE. In fact, we have some experience in this software. As the team was completely new and also we had so little time to work and think about the project as well, we began working from day one. It sounds easy, but it wasn't since the beginning that we started struggling with the simulations. In fact, with our own Linux machine, we couldn't start a proper simulation. Well, that was not the main problem because we had an online JAXA simulator, so we solved that issue afterwards. Next, regarding the decoding process itself, we did it by trial and error. And this worked pretty well, and we took a decent amount of time in perfecting the cable's movement in the space. So far so good with movement. We were able to reach the point and then look at the QR code. Then problems started to show up. How to read information in the QR code and use it the way that must be used. We spent days trying to figure this out, but the team could also solve it thanks to the GitHub community and our coach professor here in NTST, Taiwan Tech, and we were able to scan QR code and have the information that we need well. Now we needed to be able to navigate in orbit. Once we figured out how to move the robot, we made the necessary correction for such movement and managed to scan the QR code and take the snapshots we needed. Finally, the big bugger returned to give the full mission report. So that was an introduction of our team, and thank you so much to watch the video.